Hello everyone, this is grade 6, module 1, lesson 8, problem set. Today we're going to be working with values of the ratio, and it says the quotient of A and B. So we're taking our ratio and we're turning it into a fraction. Or a division problem we could say, because it says quotient, which is the answer to a division problem. Notice that the first number in the ratio is on top, the second's on bottom. Now I'm going to display this a couple different ways. So let's take a look at one first. And it says the ratio of the number of shaded sections to the number of unshaded is 4:2. What is the value of the ratio of the number of shaded to the number of unshaded? So if I go over here and count, I have shaded, which is 4, and unshaded, which is 2. So I have to make a ratio of shaded to unshaded. So there's my ratio. But I need the value of a ratio, meaning I'm going to turn it into a fraction. And I can take this 4, because it's the first one, and I'm going to put it on top. So my first value in the ratio goes on top, my second value goes on the bottom, because order matters with ratios. So I have it in a fraction form, but what we need to do is simplify this fraction down. Meaning I'm going to divide it by 1, but I'm going to pick a fraction where the number can go into both 4 and 2. And I know that they share 2, so it's 2 over 2. 2 over 2 equals 1, so I know the value of my ratio is not changing. I'm just changing it into a more simpler form. 4 divided by 2 is 2. 2 divided by 2 is 1. There's my value of the ratio. And we know that 2 over 2 or 2 over 1 equals 2. I still know that that's a comparison of 2 to 1. So we're trying to get the value of the ratio, getting it into simplest form and putting it into fraction form. So underneath here, 2 says use the value of the ratio to determine which ratios are equivalent to 7/15. So I'm going to turn them into fractions and then try to find them in simplest form. So 7 to 15 is 7/15, or 7 over 15, because the first number in the ratio goes on top, the second number goes on bottom. So I'll do A and C. And A, my first number is 21, my second number is 45. So the first number goes on top, second number goes on bottom. Now I have to figure out what can go into this number so I can divide. And I know that they share a 3, so it's got to be 3 over 3. I have to pick a number that I can divide on top and on bottom. I can't do like 3 over 5. Has to be 3 over 3 because 3 over 3 equals 1. I don't want to change the ratio value. I want to just get it into simplest form. So if I divide that out, 21 divided by 3 is 7. 45 divided by 3 is 15. So A is equivalent. If I look at C now, the first number is 3, so that goes on top. The second number is 5. Well, this one's fairly easy to determine because 7 over 15 is simplified, meaning I can't find another factor other than 1 that goes into 7 and 15. But for 3 and 5, I can't find anything either. So I can't really see how this could be equivalent, but I'm going to try. Meaning, I want to make this bottom 5 into a 15. And I know I can do it by multiplying by 3. But I know with fractions, to keep them equivalent, it'd have to be a 3 over 3. Because I want to make sure that I keep my ratio value the same. So if I do times 3 on the bottom, I'd have to do times 3 on the top. So 3 times 3 is 9. And I know that 9/15 is not equivalent to 7/15. So this one is a no. A was a yes. So that's what you're going to do for B and D. Let's slide down to 3 now. Sean was at batting practice. He swung 25 times but only hit the ball 15 times. A says describe and write more than one ratio related to this situation. So I'm going to do 2 for this one. And I'll do 3 right here. And I'm going to do A. And A is telling me to write more than one ratio. So my ratio is going to be the number of hits to the number of swings. So my ratio for that is the number of hits to the number of swings. And then I'll write my statement. And then I want to do the number of misses. So if I take 25 and subtract the number of hits, I'll get 10, and that's got to be the number of misses. So my next one will be 10 to 25, and that's the ratio of the number of misses to the number of swings. So that's A. Because it says more than one, I just did 2 of them. B says for each ratio you created, use the value of the ratio to express one quantity as a fraction of the other quantity. So I'm going to say the number of hits, and this is going to be 15 over 25. So that's the number of hits. Now, to express it as the value, I have to reduce that, or not reduce it, simplify this down using a common. And I know it's 5 over 5. So that'll give me 3/5. So my next statement is bringing this back to the number of swings. So the number of hits is 15 25ths, or 3/5 of the total swings. Meaning I can take 3/5 of the swings and get the number of hits I have. That's kind of a tough statement. So let's try another one. I'm going to say the number of misses, and that's 10 to 25 because my first number goes on top, my second number goes on the bottom. Or, and I have to simplify down 10 25ths. And again, 5, so that's going to be 2/5, or 2/5 of the total swings. And I could say 2/5 of the total swings were misses. But that's how I'm going to make these statements to describe them. That's a little challenging. C, I'm going to leave to you. Make up a word problem that a student can solve using one of the ratios and its values. Let's take a look at 4, and I'll get you set up with this one. Your middle school has 900 students. 1/3 of the students bring their lunch instead of buying lunch at school. What is the value of the ratio of the number of students who do bring their lunch to the number of students who do not? So we got quite a bit of work to do here. So the first thing I have is 900 total students. I'm going to slide over to the side to do this, and I'll go back and forth if I need to. Actually, I'll just go down way down here below, so then I can see the problem. So for 4, we have 900 students. So I'm going to draw a tape, and this represents 900. It says that 1/3 bring their lunch. So I'm going to break this into thirds. And I know that one of the thirds is people who bring, and the other 2/3 is the ones who bought. And really, I have my ratio kind of set up for me. I could do it right from there, the value of the ratio. But I want to solve it out, just because. So I have 3 boxes that equal 900, or 3 units equal 900. So I'm going to do 900 divided by 3, and I know I'm going to end up with 300. So 300 here, 300 here, and 300 here. So the people who bring, and I know that I'm looking at bring their lunch to the number of students who do not. So 300 to 600. That's my ratio because I have to do bring first, which is 300. Bought has two 300s, which is 600. The value of the ratio would tell me the first number goes on top and the second goes on bottom. And then I have to simplify this down. Well, the funny thing is, this ratio of 300 to 600, that's after I've given a value to the unit. I gave it 300. But how many boxes do I have? For bring, I have 1. And for bought, I have 2. Now I can turn this into my value of the ratio. The 1 goes on top, the 2 will go on bottom, and my value of the ratio is half, or 1/2. So when it says the value of the ratio of the number of students who do bring their lunch to the number of students who do not, the value of the ratio is a half. Because I'm comparing bring to bought, not bring to the whole amount. Because some of you are thinking 1/3, but 1/3 would be a ratio comparison of the number who bring to the total number. That's not what we're looking at. We're looking at bring, which is just 1, and bought, which is 2. Hope this helps. Thanks for watching, and good luck on the rest of your problem set.